Okay, in this video here, what we're going to do is enhance our GL engine just a little bit.
To make it better.
That's right, so that we have the ability to add text into our applications.
Right.
So as a matter of fact, Joel, go ahead and launch our cool little program that we've shown them 110 times.
Right, now.
And here it
reaching
comes.
111 times.
That's right. So what we want to do is take that title bar text up there, the changing number, 80 frames per second or whatever, and we want to draw the frame rate down into our application or our viewport area.
Right. I mean, it may become necessary at some point, and it will, to need to draw actual text inside of our OpenGL window, because that's a separate thing that we need to do.
Yeah, well, if you were creating a game and you want to have some type of heads-up display that's got text indicating your health and ammo level and things like that.
You need to know how to do that.
Yeah, and it's not like it's really a 3D object that we're rotating around.
No,
that'd be a very weird HUD.
Yeah, it's basically like an overlay on top of our 3D display. So basically, we have our 3D objects, and then in the second pass, if you will, we're going to draw our text.
Right. So in this video, we're going to show you guys how to do that.
And we're going to be utilizing bitmap fonts. So there's a lot of ways to do this. If you use Glut, you can do things like create Glut bitmap fonts or whatever that allow you to create outline fonts or bitmap fonts. But that's very, very window interface specific. Depends on whether you're using SDL, Glut, WX widgets, it changes. So if you're using, if you use bitmap fonts in which you read a bitmap font, a TGA file, load that in, and then inside of that file it has every single letter of the alphabet.
So you go through and you sample each of those different characters.
Right. If you use that way, it's very cross-platform, and it doesn't matter what kind of window interface you use, it still holds.
That's right.
And that just makes life a whole lot easier for everyone.
Which is what we're going to be doing here.
Yes, exactly. So let's go ahead and exit this and start making changes to our GL engine. Now, first off, we have a few private variables that we're going to need. I mentioned that we need to create a texture, right? And we also mentioned that we're going to need to store every single one of our letters.
So we need an array.
So we need some sort of an array. In this case, we're going to use a display list, as we mentioned before. And basically, each item in the display list is going to hold every single one of our characters.
That's right.
So let's go ahead and create two things. First is a GLU int, and this is going to be the ID that points to our font base. In other words, we're going to create a series of display lists, and the ID that points to that series of display lists is going to be pointed to in font base. It's going to be stored in font base. And we also need a texture for our font. So let's do a texture pointer font texture, and we'll create this in our initialization. Now we need some functions as well. So let's see. First off, we need a little utility function that will allow us to create our font texture, or create the display list. So our build texture font, and this will just be GL void. And then we need to be able to draw our text, so GL void draw text. And this is going to be a little bit interesting. We need to specify where in our viewport we want to draw it. So we'll do a GL int x and a GL int y. So where do we want to draw our text? Again, this is 2D. This is not 3D. So we only need an X and a Y. And then we're going to do constant char text, which basically says what text do we want to draw. But we're going to make this a little bit interesting. We're going to add a dot, 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 an ellipses at the very end, which means that we can have things like, just like with printf, which will allow us to, let me just type this out here really quick. Printf, frames per second, %f. And then we specify the frames per second. So we can do things like this with our draw text.
Right.
Very, very cool. And with that, we also need two other functions that kind of just simplify things a little bit, called getTextWidth and getTextHeight. And basically what I want to be able to do is say, I send it a certain text, like loading models or something like that. And then when I call that, I call getTextWidth with a argument of loading models or whatever text I want to sample, and it returns to me the width of that.
Right.
In whatever unit you're using. So we'll pass it a constant char text, and same for our getTextHeight. In our case, it's going to be very simple since the width of each of our characters is the same. But nonetheless, it is very, very useful to have. So with that, let's go ahead and start implementing these guys. So let me copy this whole lot, go into our glengine.cpp, and paste them in here. And let me just GL engine, scope it in, scoped, more scoping and more scoping. So with that, let me just go ahead and clean this up a little bit. Move our terminators.
Add in some quick blocking.
So block in the code. And
ready.
There we have it. Now, before we go ahead and implement, well, actually, let me really quick go into our initialize function and just do the simple initializations that we need. Right after our light initialization, we're going to need to create our font texture. So let's do a font texture, thank you, equals new texture. And we're going to create our texture. We're storing our font texture in data/font.tga. And then we're going to need to call our build texture font. All right, so now a little bit of discussion on how our font.tga is organized so that we can go ahead and build our display list, because we need to know how this is organized.
Right, so first a look at the TGA file itself.
Yeah, so over here in our folder for our source files, under data, we have our surface.tga, which we've been using to texture our cube.
Right.
And then we have our font.tga. So what does this look like? It's simply 256 by 256, and it can be any size you want, of course, that contains all of the characters we need. In fact, it contains two sets of characters. We have a single set that contains, normal non-italics font, and then italics font in the bottom here. So we can utilize either of these if we wanted to.
Keep one thing in mind. If you look at it carefully, you'll notice that we have 16 characters going from left to right.
Right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Right.
So all the way across, and same all the way going down.
So knowing that it's 256 wide,
right,
we can and that we have 16 characters.
Just to kind of simplify this before we confuse anyone. Remember, in our texture space, this goes from 0 to 1, right? And then in T, I think it is, this goes from 0 to 1 as well. And since we want to be able to use our texture to basically sample along this and create our display list, we need to calculate how much in texture coordinate space this specific width is. And if we have 16, and this goes from 0 to 1, then the width of every single cell here is 1 divided by 16, right?
Yeah.
So with that, let's go ahead and exit this out. So how do you create something like this? I mean, that's the first question that someone's going to ask. Well, there is a number of programs that can do this. But there is a Bitmap font builder, and it's free, but he does ask you to support this if you want.
So donate to him if you're going to use it.
Yeah, if you're going to use it non-commercially, awesome. But if you're going to use it commercially, please contact him and get all that worked out. But, of course, we're using this in an academic situation.
Right.
So right here we have our font builder, and all this allows you to do is you can select 2 fonts and click one button, and it'll save it out as a TGA file for you. So really, really nice. So that's what we use to create our font as well. So how does this work? Let's go back into our SDL demo, and let's just start out the code. Now, before we get to the loop, I'll go into Photoshop and make it a little bit more clear for you. So the first thing is we need to create our display list. So we'll do a font base GL gen list.
And we need 256 display lists.
That's right, because remember, we had 16 characters on the width and 16 characters on the height, so 16 times 16 is going to give us 256.
That's right.
And then we need to bind our texture. So let's do our GL bind texture so that we can utilize our font texture. 2D.
This is all stuff that we've already talked about.
Right. So I'm not going to explain it anymore. Done. And then let's also do GL enable GL blend. So that we can actually, because remember we have a black background and a white, so if we want to be able to blend it so that white kind of gets multiplied onto the screen.
Right.
So what we're going to do here is do a GL blend function.
This way we can put text over our 3D models without a big black area being
drawn there as well.
Exactly.
So remember, this is the source factor and the destination factor. So that's simply going to be the source alpha multiplied by 1, added to 1. So we're always going to add on to whatever is currently already there.
So if it's black and we're adding on to what's there, it's just what's there.
Right. Very good. I was actually surprised. I was like, wow. All right, so basically, let's go back into Photoshop right now.
Okay. And
just show you really quick how our loop needs to be set up. Because we need to loop through all 256 characters of our TGA. In fact, let me go back into our font area right here, just to show you exactly what it looks like. So we need to go through every single one of these characters in some kind of a loop. So the way we want to organize this is start from the top left, go across, go to the next line, go across, etc., etc. So how does this work? Well, let's go into Photoshop here. And let's say we have a nice square area. I'm drawing this freehand, people. I'm just really good at drawing straight lines. And basically have 16 divisions along here. And remember, this goes
from 0 to 1.
0 to 1. So
in the S direction.
0 to N in the T direction.
That's right.
So from...
I was only addressing the way you were drawing.
Yeah, I know. Actually, it is kind of confusing. Let me just draw it down here. So 0.
Now it's very accurate.
And then
1,
this
1.
is 1, 1.
Exactly.
But we want to start out on the top. So the first thing we know we need to do is how are we going to start at the very top? Well, we're going to need to do something like follows. Let's say we have two variables, cx and cy. We want this cx to start at 0 and go to 1, right?
Okay.
So cx is going to need to start at 0 and go to 1. And the divisions, we have 16 divisions along here. So like we said before, we need to calculate how much of an increment we need to add. Well, that's simple. Simply do 1 over 16, which I believe this gives us 0.0625.
Something like that.
Yeah.
0.625. That's right.
And in other words, what that means is on every loop, we're going to need to increment cx by 0.0625.
And that's just what's required. That's all our little divisions that simply add up in the end to give us a value of 1 if you do 16 of them.
That's right. But remember, when we get back to here, we need to start back again
That's right.
at 0. And this is where our modulus comes into play. So let's say we have a loop that simply goes, let's call this I, and this goes from 0 to 256. 0 to 255, excuse me. Right? And this increments 1 at a time.
Right.
And what we can do to make our CX work is, if I come down to the bottom corner here, I can say I modulus 16. So this is going to go from 0 to 15, from 0 to 15, from 0 to 15, etc., etc. And if I divide this whole thing, or multiply, if you will, by our 0.062, or if I divide this by 16,
right.
Then if this is 0, 0 divided by 16 will give us 0. And then if I bump it up 1, so 1 divided by 16 is going to give us our 0.625, which is this location. 2 modulus 16 is going to give us 2, divided by 16 is going to give us 0.0625 multiplied by 2, which is this location, and so on and so forth.
Right, all the way to the point in which it flips back to 0 again.
Right, and then starts again.
And then we start at 0 again, right.
So now all we need to do is, how about our CY? Same general idea, but we want it to only increment by 0.0625 after we've gone up to 16. Very simple as well. Our CY needs to equal CY. Let me just put CX equals here. Our
so it's
CY
just going to be basically an I over 16.
Yep, I divided by 16, and then divided again. So this whole thing
gets divided by 16.
Right, so when this is 0 divided by 16, that's going to give us
0.
0. 15 divided by 16, that's going to give us a value less than 1. So we're going to still maintain on this line here. And when we do get to 16, so 16 divided by 16 will give us 1. And then 1 divided by 16 will give us 0.625, which is this line right here.
There you go.
So that's all you really need to know to be able to create this function. Sounds kind of complicated, but once we start writing the code, it should make perfect sense.
It's not that
bad. So if I go back into the code real quick here, right back to our code, we need to create a loop, as I said, that loops from 0 to 255. So it starts out at 0 and goes to 255, so less than 256, I++.
Okay, and then we'll go ahead and set up the CX and CY real quick.
Right, so change in X, essentially. So our float I modulus 16.
And divided by 16.
And divided by 16. So exactly what we had over there.
Yep.
And then we have our I divided by 16. And remember, since this is integer division, when we do a 15 divided by 6, it's still going to give us 0. And then we cast that 0 over to float. If we didn't do this, if I was a float, then this whole calculation wouldn't work.
Right.
So then we divide by 16. So now that we have those two, remember, we need to create a list for each of these, because we've generated our list, but that's only a list of IDs, if you will. We need to start creating those.
All 256 of them.
That's right. So let's do a GL new list. So on every loop, we're going to create a new list that's going to hold another character. And what list do we want to create? Font base plus I. because we've generated 256. It starts at font base, so we just add I for every new list.
And in this time around, we're definitely going to do just a GL underscore compile, because we don't want to start printing out all of this stuff to our viewport.
Oh, no, that would be really bad.
So here's a really good example of why you'd want to only do compile.
Yeah. So then let's do a GL begin. So a GL quad. We could use triangle strips if you wanted to. We'll just use quads in this case.
Nice and easy.
Yeah.
So basically, we're just going to need 4 GL text coordinates.
And 4 GL vertex calls as well.
Yeah.
So our GL text coord to F. So our S and our T. Well, we've just calculated our S and our T, pretty much. We just need our CX. So we're going to start out at 0. Mm-hmm. And then for our CY, let me just tab over so we have some space to work with. 1 minus CY, because remember, we said we need to start at the very top. And the top of our texture is 1, because our bottom left is 0. So we do a 1 minus CY minus 0.0625. Because we need to minus 1 off of that, because we start at the base.
Right.
And then just cap that off. So there we have our first GL text coord to F.
Now we can go ahead and create the vertex.
So our vertex, and we're going to use 2i in this case. Actually, I think this is the first time we've ever used 2i.
Yeah.
Yep. And we're going to create, in other words, that's passing an integer. And remember, we're drawing in an orthographic view now. Mm-hmm. So a 2D area.
That's right.
And inside of our SDL demo, we're going to create 2 things. One that sets our perspective, which we already have, our established projection matrix. Mm-hmm. And then we're going to have a set ortho function that allows us to set an orthographic view that fills our entire window. So 0, 0 is going to be part of our coordinates, and then the width and height of our window is going to be the other part. So essentially, we're going to be working in pixels here.
Right.
Hence why we can use 2i, because we don't have subpixels. Mm-hmm. So in our 2i, we're going to pass it 0 and the size of our texture. Now, we could hard code a value in here, just say 13. And this will actually create our quad, because remember, we're putting this into a list. So 0, 13 would actually give us a quad that's 13 size. But we want to go ahead and put this in some sort of constant. So what we're going to do is come up to here and do a constant int font size. We're going to equate this to 13.
Okay.
And we'll also create a font space as well. And where this comes in handy is we do need to space our text out,
sure.
right? So if we want it to be more spaced out, we can go ahead and change this constant. We'll just initialize it to 7.
Okay.
So with that, let me go ahead and copy and paste this 4 times, just to make my life a little bit easier. So this next one is going to be add 0.625. And this one right here is going to have the same coordinates, CX 0.0625. Is this all good?
Yep, just work. Guys, if you're having any problem with this, just simply draw this on a piece of paper.
Yeah.
That'll make it a lot more clear.
Yeah, as we did in Photoshop. It should be really clear once you see what's going on.
Go ahead and push it. Yeah, there you go. Nice.
I didn't change this to font size. I created the constants but didn't use them. So then...
Yeah, font size.
Font size.
Comma font size.
Comma font size.
Font size, comma 0.
Font size, comma 0.
And 0, comma 0.
0, comma 0. So there we have it. And if we wanted to flip the text and make it upside down, it's pretty obvious that we can go ahead and change these vertex.
Exactly.
And then it's opposite.
Right.
Of course, I don't know why you'd want to do that, but...
You never know.
You never know. So once we've created... we have our GL new list. We've created our quad. Now let's go ahead and move it over, because in the end, what we want to be able to do is draw a particular line of text, right?
Right.
So if we want to draw move, let's say, we want to be able to write M-O-V-E, but we don't want to draw it all on top of each other. We want to be able to write a move, have it translate over, write the O, translate over, write the V, and then translate over, write the E. So we're going to need a GL translate D, so this is for double. And then font space. We could use, in fact, we could use I if we wanted to. We'll go ahead and use double. And so we're simply translating in X here, because that's all we really need. And then once we've created that, we just do our end list. And it loops through and creates all 256 for us.
There you go.
So that is all there is to creating our texture font. Well, that's actually quite a bit, but still, it's not too bad.
Basically, now we just have a display list. We have 256 display lists, all containing a single quad that has...
Each individual character.
That's right, each character. With the texture already on it, with texture coordinates.
Yep. So we're going to actually utilize this text now. So let's do a char text with 256.
There we go.
because what we need, we're past our text, right? Let's actually call this in text so it's not confused with text here.
Yeah.
But we have this ellipses that allows us to pass in decimals and everything. So we're going to create a local variable called text that stores the final version of this. So if we pass, FPS colon %D, the final thing may be FPS colon and then 75 or something like
Sure.
that. So we actually need to store that final bit of text inside of here. And we get very nice structures inside of C that allow us to do this. And the VA list is what allows us to store the list of pointers. So we'll just call this AP. And then do a VA start, which starts getting the list and compiling into our final text. So we pass it our list of pointers, AP, and our in text, which is what's passed to us. So we want to start parsing this. And then we do our VSPrintf, and then pass it where we want to put the text. We want to put in our local variable called text, and then pass it in text. This is where we're getting it from. What are our arguments? We're in our AP. And then we simply do a VA end and pass it our AP. And then by the time we get to here, everything that we need is stored inside of text. So we just need to print whatever's inside of text.
Exactly.
So first thing we're going to do is do a GL enable texture 2D. Because just in case the user may have disabled textures at this point, go ahead and enable them again. And we also want to do a GL enable GL blend and our blend function set it. Because if they're utilizing transparency, simple transparency, they wouldn't be wanting to use GL blend func. Or if you're not using blending at all, they may have disabled it. So
That's
go
right.
ahead and enable it for ourselves.
It's just a safety precaution because you just don't know what the user may have done.
Exactly. And then we need to bind our texture. So let's do our GL bind texture. And now we also want to save our, because remember we're going to do a translate here so we can move our text to the right location. So let's push and pop our GL matrix, our model view matrix. So let's set to our model view matrix, and then do a GL push matrix, and load our identity so that any transformations that are already there are loaded back.
That's right.
And then what we need to do is do a GL translate D, X, Y, and 0.
So obviously you guys can see why we pushed our model view matrix.
Yeah, because we just did a trip.
Yeah, we're mucking with it, and we want to make sure when we hand this back to the user, they're back to wherever they were at.
Exactly, because we don't want this. This is a utility function. Anytime you create a utility function, after calling it, it needs to be back to whatever state it was before. Absolutely. So once we've done that, we're going to set our GL list base. And this will become clear in a second. Let me just type this out and then explain it once I have the second line in here. And then I'm going to do a call lists. So I'm going to call multiple lists here. I'm going to pass it the length of our text. So string length text. What kind? GL byte. And then pass it our text. So what is this doing? The first thing is we're saying list base says which list do we want to work with? Because call list is going to actually start calling a bunch of lists. So GL list base prepares that by saying which set of lists we want to call. And we do a font base minus 32 because if we look in our F check here, this does not start at ASCII character 00. It starts at the space. And space, if everyone remembers, is of decimal 32 in the ASCII chart. So if we minus 32, it's going to start out here. And then when we do our call list, it's going to, because we don't expect to have any functions that are below our space, because these are what's displayable on our screen.
That's right.
So we minus by 32, and then when we call our call list, we pass it the number that we want to call. It's going to be of type byte, because each one's a character, and we pass it our text pointer, which is going to loop through our character array and push each one and call each one.
Cool.
And then all we need to do is restore our matrix, so just in case something, because remember, a list could be modifying our matrix mode as well. So we need to go ahead and reset our model view matrix to our model view, and then do a GL pop matrix. So we're returning it into the right matrix. And that should be it. So finally, let's do our get text width and get text height. So let's do a return string length text. And remember, we're just doing font space here. Because remember, we did GL translate according to font space, so we simply need to pass the length of our string multiplied by our font space. And finally, we do a return font size. because text height is always going to be the same. We do pass in our text, and this brings up another important thing. In this case, our text is basically fixed width, right? Every single one's the same width. If you wanted to implement something like Arial or some other font like that that's non-fixed width, you could save out the text information, load it back in, and in that case, your get text height would need to utilize this parameter, and your constant your get text width would be a lot more complicated because it'd have to read in every single character of text and calculate the width of each one of those.
Right.
But in this case, it's really simple. Just return font space times length of the text.
Cool.
And so finally, let's go ahead. Now that that's created, let's see if it compiles okay.
Very nice.
Very nice. There's some warnings, it seems.
Just a few.
Okay. All right. So some simple things here. Let me just put our F here. That should fix it. Yeah, that fixes those two. And okay, from this could be cast to a GL size I. And then finally with this one, okay, we're returning a GL unsigned integer and not casting it. Right. So we could just cast it, and that should get rid of those two. All right, there we go. I just like no warnings.
I know it.
So with that, let's go back into our SDL demo, and let's change over our text to start utilizing that.
Okay.
So we have our initialization. So we've already initialized OpenGL. But inside of here, notice we have inside of our display FPS, we have this SDL set caption. We're going to remove this. Let's just copy this out of here and paste this down here and call IGL engine draw text. And notice we have this whole create a local variable, then do an sprintf, and then set the caption. Now, all we need to do is copy this entire thing, set where we want to display it, let's say 5.5, and then copy and paste that in here. Because we automatically support having %.2f, and we pass in the actual FPS.
Right.
So that saves us from having to create a local variable, which is really nice. And notice I brought this out of this if statement because now inside of OpenGL, we need to call it on every single refresh, right? And before, we just kind of updated it whenever we felt like it. Now we need to draw the FPS on every single call.
That's right.
So in our draw scene, what we need to do is at the very bottom here, first thing is bring this display FPS before the flush. Because now, remember, before, display FPS wasn't calling anything OpenGL related. Now we actually have to do it before we flush out the buffers and do the swap buffers.
Right.
So now, we have the draw cube, which is in 3D space. Then we do a display FPS. Well, what does this mean? We're still in perspective mode.
That's right.
And what that means is our text won't display. In fact, if I compile this, just to kind of prove it to you, if you will, if we run this, no text is being displayed. I mean, you can't see anything that's going on. So what we need, and you'll notice that our cube is now being blended, which is a bad thing. Because remember, we turned on GL blending when we created our font texture. So a few things we need to change. We need to create a function that sets to our orthographic projection. So how would we do this? Well, let's do a GL void, and we're going to do a set ortho. And we're going to pass it two things, a width and a height. So our GL size I, our width, and a GL size I for our height. And much the same as we do with our established projection matrix, we'll copy all of this and bring it down over to here. So we load our identity. Actually, let me clean this up just a little. So once we've loaded our projection matrix, reset it to its original state, we now need to either set it to perspective or orthographic. In this case, we need to set it to ortho. So a simple call to GLU ortho 2D, passing it 0, comma, width,
comma,
height, and then 0. So this is going to work much like a regular window inside of our viewport.
So it's kind of like we're dealing with an overlay now.
Yep, it is.
Yeah.
Which is really cool, actually. So with that, let me go down to our draw scene area here. Now we're basically going to have two passes. One in which we need to basically set to our GLU ortho, a GL perspective. At the very top here, we're going to do a GLU establish projection matrix. Spelled that totally wrong. Establish projection matrix, and we're going to pass it, is it screen width, or I think I called it window width. Window width and window height.
Okay.
And at that point, this now establishes it as a 3D area, because now we have two passes. Let me just actually block this in. Pass 1. Pass 1 is perspective, right? And then our pass 2, in which we draw our overlay, if you will, in which we draw any text information or any other 2D stuff, we put that in our pass 2. So once we've drawn our 3D cube down here, we step into phase 2, pass 2, in which we need to call set ortho.
Yeah.
Is it called set ortho? Window width. I might have spelled it wrong. I'll see in a second. Window width and window height. So once we've set our orthographic mode, we can go ahead and display our FPS. But there are a few things we need to call inside of that. Remember a second ago, our blending was totally messed up. So what we need to do right here is do a GL enable, or GL disable, GL blend.
Just so that when we get back into the first pass or into our 3D, we don't have our geometry all transparent.
Yeah, which would be bad. And another thing we need to do is disable lighting when we get to our orthographic area here. So let's do a GL disable
GL lighting.
GL lighting. Let me just see what that does at this point.
Okay.
Very funny. I had a semicolon at the end here. No wonder I didn't recognize the name. So let's see what this does. Notice it already works here. So, but notice our GL lighting, because we disable it, we're not re-enabling it, so our cube is no longer lit.
But at least it's not transparent.
At least it's not transparent. That's a step in the right direction. But now our text is being displayed inside of our viewport using our bitmap. And notice how it seems anti-alias, which is another kind of positive side effect of using bitmap fonts, because it's 256 by 256, and it kind of stretches it up a little bit, or stretches it down dependingly. So we get automatic filtering for our text, which is a really nice benefit. If we were to use outline fonts, which means it would use things like GL quads or GL triangle strips to draw our text, you would still get jaggies like you do inside of your 3D viewport. So that's kind of a benefit that you naturally get from using a bitmap font.
But Joel, of course to them it's going to look very anti-alias because, well,
that's true.
The codec, the compression of the video, the size, etc.
Yeah, you're going to get super anti-alias.
Yeah, no kidding.
So let me just fix this lighting thing.
Yeah.
So if I come back down into my, let me just give myself a little bit more room here. So right before our pass 1, let's do a GL enable GL underscore light. GL underscore lighting.
You can do it.
I can do it. And simply F5 it. And
beautiful.
Beautiful. There we have our final box.
Yeah.
So with that, I think that's everything that we wanted to show.
So our
in this
GL
lesson.
engine has now been set up to accommodate the drawing of text.
Right.
That's the most important thing. Of course, don't forget you've got to have that font.tga file or whatever you ended up calling it.
Right. And there's basically two things that you really need to keep in mind here. One is that you need your font.tga, because otherwise you're going to see like white splotches here, gray splotches, and that's bad. And number two is that we need to have two passes, one in which everything we draw is in perspective mode.
Right.
And then we need to draw another pass in which everything is in 2D mode. So you have two basic sections. You could interchange them in which, while I'm drawing this, I switch over to orthographic mode, draw something, switch back to but then that gets really time intensive, and you basically want to separate it so that you only have to do...
Not only that, it becomes a little bit more confusing as well. It's going back and reading over. And just for anyone who's completely new to this stuff, don't get confused with thinking when Joel says two passes that basically we walk all the way through the loop one iteration, and that's considered one pass. And then going back to it a second time, we're doing our second pass. In one iteration through the loop, we're basically handling all of our 3D stuff. Then we're handling all of our 2D stuff.
Right. We can just consider it two steps if you want to.
Two steps within the iteration
step one,
of the
perspective.
loop.
Step two, we do non-perspective.
Exactly. So really, that's it. Now that we've got our GL engine set up where we can do text, we're ready to move forward into some far more interesting things now.
Awesome.
So that is going to wrap up this video on creating and displaying text. Thanks a lot.